Hello everyone. In today's lecture, we will discuss an important skill in economics, understanding and interpreting graphs. Economists always use graphs because they allow us to simplify complex information and identify relationships among economic variables. Throughout this course, you will see simple graphs showing many economic indicators. So, why do economists rely on graphs? One major reason is that graphs help us visualize economic models. Economic relationships are often complicated and involve many numerical values. Instead of looking at long tables of data, economists can use graphs to present information in a way that is easier to understand. Graphs serve as simplified economic models. They help us understand how one variable responds when another variable changes. For example, we might examine how consumer spending changes when income increases, or how unemployment changes during a recession. Before moving forward, let's define an important term, a variable. A variable is simply a quantity that can take on different values. Examples include GDP, inflation, unemployment, income, and prices. Graphs are also useful because they help us recognize patterns. Economic data often contains thousands of observations. A graph can transform those numbers into a visual picture that allows us to identify trend, cycles, and relationships. Before looking at graphs, we must understand the different types of economic data. The first distinction is between nominal and real values. Nominal values are measured using current market prices and are not adjusted for inflation. Real values are adjusted for inflation and therefore provide a better measure of actual economic performance over time. We will talk about later. For example, nominal GDP measures the value of production using current prices, while real GDP removes the effect of inflation and focuses on changes in actual production. The second characteristic of economic data is frequency. Economic data may be reported monthly, quarterly, or annually. For example, unemployment data is often reported monthly, while GDP data is commonly reported quarterly. A third distinction is between stock variables and flow variables. A stock variable measures a quantity at a specific point in time. Examples include national debt, wealth, or the money supply. A flow variable measures activities over period of time, like GDP, income, and government spending. Understanding these differences helps us interpret economic graphs correctly. Now let's discuss where we obtain economic data. One of the most popular sources is the Federal Reserve Economic Data Database, commonly known as FRED. FRED provides numerous economic time series from government agencies, research institutions, and private organizations. It is widely used by economists, researchers, students, and policymakers. Another important source is the Bureau of Labor Statistics, or BLS. The BLS collects and publishes information about labor markets, unemployment, wages, inflation, productivity, and working conditions. Whenever you hear news about unemployment rates or inflation figures, the information often comes from the BLS. A third important source is the Bureau of Economic Analysis, or BEA. The BEA produces official measures of GDP. and personal income, and business activity, and many other macroeconomic indicators. Let's start with bar graphs. Bar graphs are useful when we want to compare a single variable across several different categories. In a bar graph, each bar represents a category, and the height of the bar represents the value of the variable being measured. For example, suppose we want to compare GDP growth rates across different states. Each state would appear as a separate bar, and the height of each bar would indicate each rate. Bar graphs are effective because they make comparison easy. We can quickly identify which category has the highest value, the lowest value, or how large the differences are between categories. Another graph commonly used to display a single variable is the pie graph. A pie graph shows proportions of a whole. The entire circle represents 100% of a total amount. And each slice represents a category share of the total. For example, if you want to examine the composition of GDP by sector, we might divide GDP into agriculture, industry, and service. Each category would occupy a portion of the pie according to its contribution to total GDP. Pie charts are especially useful when the objective is to show relative shares rather than the price numeric values. One of the most important graph types in economics is the time series graph. A time series graph plots data over time. Typically, time appears on the horizontal axis, while the variable being measured appears on the vertical axis. This graph allows us to observe trends, fluctuations, and changes through time. And in the right hand, you can see inflation rates and core inflation rates from 2014 through 2024. You can see how inflation remained relatively low for many years, increased sharply around 2021 and 2022, and then began to decline afterward. Economists use time series graphs in many cases because many economic variables change over time, like GDP, unemployment rates, inflation, interest rates, and stock market indexes. So far, we've looked at graphs with one single variable. Now let's look at the graphs with two variables. A scatter plot displays the relationship between two variables. Each dot on the graph represents one observation. For example, 1 point might represent a country, a state, and a company. Scatter plots are useful because they allow us to identify correlations. A positive correlation occurs when two variables move in the same direction. As one variable increases, the other tends to increase as well. For example, income and consumption often exhibit a positive correlation because people tend to spend more as their income rises. A negative correlation occurs when two variables move in opposite directions. If one variable increases, the other variable tends to decrease. For example, unemployment and economic growth may exhibit a negative relationship. It is important to remember that correlation does not necessarily imply causation. Just because two variables move together does not mean one variable causes the other. Thank you for watching.